Hello guys, can you hear me?
Yeah,
How are you guys doing?
good at you.
Mr. J, how are you?
I'm okay.
The home girl told me what happened, so take it easy, yeah?
Thank you.
Welcome. So, guys, today I couldn't make it to the campus, so I decided to get this for you because I want us to finish this chapter today. I mean, this section we need to cover in this chapter, which is the normal distribution. I want it to be done today, and we're almost done. We are just a few things, and you know, will now be good for the week. So we begin today by rounding this chapter with a topic called the central limit theorem. I'm sure, let me move this down so you can have an outline here. Central limit theorem. So the central limit theorem is, basically what it's saying is somebody that when you select a sample randomly from a population, when you select a large sample for a population, then the sampling distribution of the sample mean becomes changed to normal distribution. Let me put it the way I stated it here. Now, if you have a population with mean, okay, and then that population have the standard deviation of delta, and you take sufficiently large random samples from that population, with replacement, then what the central limit theorem is saying is that as your sample size approaches infinity, that means as it increases and approaches infinity, the sampling, the distribution of the sample means will approach a normal distribution. That's the simplest way to describe it. In other words, as the sample size increases, the sampling distribution of the sample mean will approach normal distribution. And not only that, it approach normal distribution, it will have a mean that is equal to the population mean, okay? And the standard deviation that will be equal to the population standard deviation divided by the square root of the sample size. So that's what it's saying. So for under the central limit theorem, we transform the normally distributed variable using this formula that you see below. Z equals S bar, which is the sample mean minus the population mean, divided by population standard deviation over the square root of n, where n is the sample size. So on the ones we did before, we are using this simple formula to transform, which is this one here. But this time around, the sample size is not included. And then the sample mean is also included. So there's become a modification of the rule, okay? Of the rule. It becomes this one. X bar Z equals to S bar, which is sample mean of the population mean divided by the standard deviation over the square root of the sample size n. Now, if you're asked to find the standard error, or what they call the standard error of the mean, we use this formula here. But if we are looking for the transformation, we use this one here. Okay. Right. So let us see how we can apply it in real life situations. Now, when we look at the first question we'll be solving here, it says here that AC Nielsen, yeah, is a polling company. They do political polls, said another type of polls, of course. AC Nielsen reported that children between ages 2 to 5 watch on average 25 hours of TV a week. And assume that the variable is normally distributed with a standard deviation of 3 hours. If 20 children between that between age of 20, if 20 children between the age of 2 to 5 are randomly selected, calculate the standard error of the mean. Now, we are told that the mean is how many hours you watch TV? 25 hours. And then the standard deviation is 3 hours. Okay. Now, if they watch TV, how many children were selected? 20 children were selected, and yeah, 20 of them were selected. So n is 20, and the standard deviation is 3. All they want us to do here is to calculate the standard error of estimate. So it's not really calculate the standard error of the mean. So the formula for that will be, I'm gonna this place will not allow me to put it, so I'm gonna go to what we have enough room. Let me write this down. N is 20 and standard deviation is 3. So let me take you to the other workbook where we can put this in and get the standard error of estimates. Okay. So that the standard error of the estimate will be this a bit. Standard error of the mean. I'm going to use standard error of the mean equals, and we make this to be error. Going to be equals standard deviation of over root n, the standard deviation divided by square root of n, square root of n, and that will be equal to. Now, going back to our work, we were told that the mean, the n is 20 children, and that the standard deviation is 3. Now, all we have to do is to go there and put them in. 3 by the square root of 20. Okay, 20. Which we can get from the calculator. Mean of standard deviation divided by square root of 20. 0.671 rounded. 0.671. Okay, now you can copy it and paste it there, and that will give us the answer for the standard error of the mean. Okay. Any question on this one?
No.
Good, excellent. Now let's try another example. That is what it says. This one will involve the calculation of probability. It says here that there is a large supply of energy saving light bulb with average life of 890 hours and a standard deviation of 50 hours. A random sample of 49 light bulbs is drawn. A, calculate the standard error of the estimate. B, find the probability that the sample mean will be less than 1,000 hours. Assume that the lights of the light bulb are normally distributed. To answer this question, we have solution. Part A says, but before that, I want us to write out the mean and the standard deviation. So let me write some of this plain out because I need the symbols. Okay. The solution. So the mean, I can insert the mean from here. The mean equals See the mean average of 890. And the standard deviation is 3. Then a sample of 30, right? So not 3, sorry, my mistake. Standard deviation is 50 hours. So 50 hours. And the sample size is selected 49 on light bulb 49. Okay. And after those 49 light bulbs, they want us to find the standard error of the mean. So I have n as 49, delta as 50. So let me write it down. N is 49. Delta, the standard deviation is 50. So to get the standard error of estimate, we just go back and put them in. Formula is standard deviation divided by the square root of n, which means our standard deviation is 50. Over the square root of n, our n is 49. Okay. So now let's answer this. 50 divided by the square root of 49. On a calculator, we can get that. 50 divided by square root of 49. 7.143. Okay, 7.143. 7.143. So it's standard error. I'm going to copy this and then paste it on our main workbook. Okay, that answered part A. Okay, now part B says find the probability that the sample mean will be less than 1,000 hours. Assume that the lives of the light bulb are normally distributed. So to answer that, we have to just write part B. Let me put down the summary statistics here. Okay. Okay, I have it right here. And it says sample mean is less than 1,000 hours. So our sample mean S bar is 1,000. So I can't get that character from here. So I'm going to get it from the other workbook. X bar is I get it from here, 1,000 hours. X bar equals 1,000. So I'm going to copy this and put it there. $1,000. Okay. Now we're ready to answer the question. Now, this time around, we're going to use this formula here, just to this one here. Okay. So now let us transform everything we need. So we have, let me write them down and then we can go and transform it. I got n is 49, delta is 50, mean is 890, and then the S bar is 1,000. So let's go and transform this. I'm gonna put it on the formula here. Z equals, okay, X bar minus the mean divided by the standard deviation of this by the square root of n. Square root of n. Okay. Again, one more time, you see that, remember that our n is 49 and our delta, which is the standard deviation, is 50 and mean is 890 and S bar is 1,000. So we put all this into the formula there. So we have this. I got 1,000 minus mean of 890 divided by standard deviation of 50 by the square root of 49. So let me write this down so we can get it from the calculator. I got Z equals 1,000 minus 890 divided by 50 over the square root of 49. Okay. Okay, now let's go and get it from the calculator. Okay, we got 1,000 minus 890 divided by standard deviation of 50 over square root of 49. I got 15.4. 15.4. Okay, 15.4. So I'm gonna copy this and paste it in our memo book. So here. Okay, 15.4. Now, it is no longer X bar, it is now Z, and it is no longer 1,000, it is now 15.4, which means that the probability that the sample mean will be less than 1,000 hours becomes the probability of Z less than 15.4. Just like we normally do before. To answer this, it's gonna be make it 16. Answer this, we need to make the chart. Okay. The chart, I'm gonna make this into be 18 or 16. So the chart will go like this, as usual. I got 0, 15.4. Okay, that's what it says. Now I'm gonna put the x-axis. The x-axis right here. Okay. They have put the bell curve. Make some adjustments here. Okay. Okay. Now you can put the distance center line here, and then put the line that represents 15.4. Yeah. It says the probability that to be less than 15.4. That means from here down, less than 50.4. So we're gonna shed from that spot backward. Okay. So you have, can use this drawing tool to shed it. So I got see. So now, once we have this, we can now, as usual, we go to the procedure table to look at the chart that looks exactly like that one. We look at the procedure table. That's that it is this one here. Okay, it is this one here, this one on the left side. Make sure I send this. Yep, seeing it. This one looks like our chart. See? So what does it say there? It says look up the Z value to get the area, add 0.5 to it. So first of all, let's find the area. Okay, I'm gonna take you to the the table of normal distribution. This one here. Then you look at 15.4. 15.4. It's a add 0.5, so we're gonna put 0.5 to it. Then we can now look for 15.4. That's this one. Okay, on the chart. Now, unfortunately, we don't find 15.4 here. Okay, it's not there because the highest we have there is 3.6. And you notice that after that, all the answers will be 0.4999 and 0.49, all of them 0.4999. And it says here, for values that are greater, for values of z greater than or equal to 3.7, use 0.4999. So that means we're going to use 0.499. Now, if you can find this number on the table, then you use the area that is there in that you found it. But if you can't find it, use 0.499. That's what it told us to do. Yeah. So we use that. We add this, you're gonna get 0.999. So in other words, the probability that the sample will be less than 1,000 hours will be 0.9999. Any question to that? Any question, guys? Okay. There's no question. Good. Excellent. Excellent. Now, this question can be, since there's no question, let's solve this last one here. This question can also be asked in a different form. Okay. Well, this is applications. Okay. So I'm gonna write all this down so we can now use let me just pick this one there since this will not allow us to pick that. So now we have, it says here, making it 18. See, the mean annual salary of environmental compliance specialist is $66,000. A random sample of 35 specialists is selected from this population. What is the probability that the mean salary of the sample is less than $60,000? Let me make it more than. Okay. You say less than $60,000. Let's leave it the way it is. Assume that the standard deviation is 12,000. So we have this here. How many of them were selected? 35. So we're going to change this to 35. Standard deviation is 12,000. Mean, if the means annual salary of environmental compliance office specialist is 66,000. Okay. Now it says, what is the probability that out of this 35 specialists selected, that the mean salary will be less than 60,000 as expert? Okay. Which we cannot get from here. We can get this only from the other workbook. Expert 60,000. Okay. Maybe we can get it. Expert 60,000. Copy this. Okay. And paste it right here. Now with this, we can now transform 60,000. So let me write this down so we can go and transform it. Okay. That N is 35. Standard was there 35 of them selected. 35 right here. Standard deviation is 12,000. Population mean is 66,000. sample mean X bar is 60,000. Okay, let's go and transform this. We got your workbook. Z equals X bar minus mean divided by the standard deviation over the square root of n equals 60,000 minus 66,000 divided by the standard deviation of 12,000 over the square root of n, and our n in this case is 35. So let's go and put this in. C equals 60,000 minus 6,000, but standard deviation of 12,000, the square root of 35. Okay, let's do it. Let's do it. Yeah. In Excel, I'm sorry, in a calculator, we got 60,000 minus 66,000 divided by standard deviation of 12,000 over the square root of 5. 82.96. 82.96. Okay, rounded. Okay, let me put it. Go and put that in there. 82.96. So we're gonna copy this and paste it in our main workbook. Okay. Now it is no longer 60,000. It is now negative 2.96. And it's no longer S by it's now a Z, which means that the probability that the mean salary or the sample is less than 60,000 will be written as probability of, and I'll make this to be 18. The probability of Z, it says less than, right? Less than 60,000. So in that case, it's going to be Z less than. Negative 2.96. See? To answer that, we need a chart. We draw our chart, negative 2.96. 0. Okay. We put a chart in. Can we see? Okay, this is it right here. Okay. Okay. Now, you can now put numbers in the center line first of all. Yeah, and they put the line that represents negative 2.96. Yeah, now less than that be this way. So you're gonna share that. Okay. Now, you can now go to the procedure chart. So look, before we do that, when I tell you this is located at the tail, left tail, yeah? And then, at the tail, whenever it's at this, I see it's at the tail. And it says, when we go to look for the chart, excuse me, I'm gonna have this. Let me share it. You can see one is at the tail. This is the one that looks like the left tail. Looks like what we have here. Okay. So it says, look at the zebra to get the area, subtract the area from 0.5. So what answer we get? We might subtract from 0.5, 0.500 minus, I'm looking for 2.96. Not negative. Negative sign, if you're using this table that we are using here, negative sign just means that it's on the left side. That's all. So when you're looking at the table, you'll be looking for 2.96, not for negative 2.96. 2.9 under 6. Okay, let's see it. Okay. 2.9 under 6. And you look for it on the table. You can see 2.9 here. Okay, 2.9 right here. Then you're gonna go under 6. 6 is 6 right there. 2.9. That's 0.4985. Like that. 0.4985, right? 96. 0.4985. Okay, 4.985. 0.4985. That will give us the answer we're looking for. So 0.5 minus that. What? 0.5 minus that. 0.5 minus 0.4985. Could be 0.4985. 0.5000. Okay, that's gonna be 4 digits. Minus 0.4985. Okay, so 0.0015. Yeah. 0.0015 is the probability. So that the probability that to be less than 60,000 will be 0.0015. Any question on this? Any question? Okay, then let me check your attendance. I have some of your names already, but if you don't have, if you don't have any question, then just as soon as I finish taking this attendance, you're free to go. All right, we got Alison, Skillison, right? Okay, I got that one. Grace. I got that one. Okay, I got it. Campbell. Got her. Iana. Who's Iana? This is Iana. Queen. Got her. Yeah. Got her. Swear. Alan. That's I think this is right there. Okay, I think Michaela Moore. Okay, Olivier. Got her. Ethan Shen. Watson Shen. Okay, got him. All right, guys, I got all your names. I see you guys next week. Enjoy your weekend.
Have a good weekend. Enjoy your day.
Have a good weekend, Professor.
You too.
Have a good weekend.
You too, guys.
Have a good weekend.
You too, ma'am.
Have a good weekend.
You too.